I think we're back on. This is so obnoxious. I think the stream is back up. Super obnoxious. I think we're back. It's gonna take a second to refresh on all the platforms before I continue with this. I'm gonna try tonight after the stream. Maybe I'll stop like 20-30 minutes early. And then I'll like update OBS and try some stuff, and hopefully that'll be better. I This is not happening consistently, but it's been happening enough that this is like really obnoxious because it cuts my VODs into chunks as well. So like I don't get like the full day VOD just auto posted on all the platforms. Really obnoxious. And then it spams my my X feed as well with like posts of the reconnects. So whatever. I'm gonna continue with this like walkthrough of stuff because this is partially for my own thoughts, and hopefully people catch the majority of it and ask if they miss part of it. But basically, if you're in this chunk here, if you split the map into chunks and you're in this chunk, then all you need to do in order to find every possible agent that you need to be able to see is you look through the entities in the surrounding chunks as well as in your own chunk. And this is because, like, if you're at the corner over here, right, you still need to be able to see, you need to be able to see potentially this far. And then you do distance checks and filter based on that. So this is how the algorithm is supposed to work. And if it, by the way, if the connection drops again, I'm just going to take however long it does to just update OBS immediately. If not, I'll just stay on until we're done. So there are a few issues with this, though, especially because I hate to say it, but this is kind of where like we start to need C++ data structures, which I didn't want to include in Python. I do have access to them. I didn't want to include them. But the reason for this is that, let's say that I look into this chunk here. Right, well, this chunk, we kind of need a list of like agent, right? Agent 1, agent 2. And this list, we need to get into this, for this list, we need O of 1 access, not lookup. We need O of 1 add and delete is what we need for this, right? Yeah, so we need O of 1. Actually, we need, I don't know why I wrote it like that. We need O of 1 lookup, add, and delete is what we need. We can do this. So if this structure is, So we use a linked list. And this is actually a 2x. It's a double linked list. Then this gives us add and delete, but not lookup. So then in order to get lookup, we would need to store the pointer to the entry in the list. We need like agent. We would need like node. We need to know the node index or chunk. IDX maybe. And then we need to know oh, this is now on my camera. Hold on. So we need to know the chunk index, and we also need a pointer to the node. And the reason for that is, like, think about it. When you move the agent from one tile to the next, we basically, what we need to do is we need to look up whether we're moving at chunks. So we look up our current chunk index, we look up the index of the chunk that we're moving to. That's just math. And then if we do move to a different chunk, then what we need to be able to do is O of 1 look it up in that list, which if we just have a pointer to the node in the list, that gives us it. And if it's a doubly linked list, then we can snip it out of the list in O of 1. This works, it's just really freaking complicated. To do this correctly. Because this is now also like, if you're doing this with the linked list, then you also have dynamic memory allocations potentially, which you don't want. Like, this is totally doable. It's just, is it worth it? I'm trying to think how much this buys us. This still doesn't trivialize stuff, right? Even with this fancy data structure. Frickin'. This web UI is bad. This still doesn't, even if we have this, it doesn't trivialize it, because you'd still want to like filter what agents are near you, what agents are far away, right? Which is still going to be slow. You're also doing this chunk lookup stuff now, which means instead of just going through a simple array, you're going through linked lists, which we're going to assume that has a decent constant factor on it as well, right? You're doing iteration through 9 linked lists. I think that in principle, this makes sense, and this could work, and this essentially would solve the problem of having an engine that is capable of doing really good entity-based learning. This would solve that problem. This ain't trivial, though. I wonder if there's like some existing C++ library or something that does this. There's probably like a C++ like chunk system. I don't know if there's a one that's as high perf as I would want, though. You could totally just like get one of these things, though, and then plug it into any game you want. Well, this is fully generic. This is like completely generic. Is there like a C++ chunk implementation? Like map? I don't know what it would be that you'd look for. But that's totally something that I could build that would make this type of stuff work. It'd be a little tricky as well because you need to do like vision stuff, maybe. Maybe not. I think this is a fun exercise, and I think that this actually gives us a valid solution to like doing ultra fast entity-based processing. But this would need a much more compelling use case, I think, than this. Yeah. It is somewhat annoying that the vision range is so limited at the moment, though, right? Only 5 tiles of vision is really not a lot to work with. Like 5 in any direction. I think that's what we have it set to. Which is, I think, what we did with Snake that we figured out we could handle. We could comfortably handle that. I mean, that basically just gives you local obstacle detection, right? I think it'll still be enough to give you interesting training results. Which is what we're after. If we were like 10x off of the performance goal, I would probably try to do this. Because like this is the type of thing that gets you your performance goal. It's very hard to implement something like this, but when you do it right, this is what gives you your perf goal. But I think for what I have now, I probably can get there more easily with the current structure and a few changes. Though it does mean I'm probably going to have to copy paste some code because we're going to have to get rid of this double iteration thing that's going on. Some limitations for sure. But I think this will be good enough. If I tried to do this thing, this would be potentially multiple additional days of work for this. And I'm going to keep this in mind, though. Because this is a good standalone project right there. This is the type of thing that you would actually do in native C or C++, by the way. Like this thing here, this is what you would have. You would implement this in C or C++, and then you would plug it into every single like game sim that you write thereafter, and you'd have like really good entity-based processing. Lots of games have something like this. Lots of games have something like this with the chunk system. But I would wager that the vast majority of them are not as optimized as I would need it to be for this. Like, you need a really optimal chunk implementation. Let's take a look at what we have going on currently. Oh, and I mentioned this before, folks, but if the stream goes down again, I'm just going to take however long it takes to update OBS and see if that fixes it. Because the internet, I think, is blipping, but the internet's blipping for like a second, and then OBS is blipping for 2 minutes. So I don't know what's wrong. Okay. CMOBA, PyX. Right, we were looking at the HTML version. Let's go back to that. So the plan right now, so I can do this in a reasonable time frame. I actually should probably go make my shake first. So I'm going to outline the plan, take the 3 minutes or whatever to make myself a shake, and then we're going to implement it. We're going to do a little bit of caching. I'll go through the plan. We're going to do that. It should take about an hour, and then we'll have, an hour, hour and a half, maybe 2 hours left for reinforcement learning policies tonight, which is about on track with where I wanted the project to be anyways. So this is the performance critical piece of code. One very, very minor optimization is I'm going to get rid of this addition right here by doing this as like y minus radius, y plus radius, so on and so forth, so that we don't have the addition in the inner loop. Then I'm going to do... is there anything else that can be pre-computed here? No. So I'm going to do that. Let me see if there's any other places for obvious optimization. Into player Y, player X. This is fully discrete, so I'm going to allow you to pass in. No, this is fine. Yeah, so... I'm going to move this target type down because you don't need it immediately. I'm going to maybe reorder these a little bit in terms of how common they are. We're going to see what we get out of that. And then what I'm going to do, and this is the part that pains me a little bit, but I don't think that we can have this structured the way it is. I think I'm going to make a code commit first before I mess with it, because this could potentially just screw up a bunch of the nice code that we have here. But this like scanning idea was cute, but the way that we're scanning doesn't allow us to cache anyways without making a massive data structure. Well, hold on. Maybe it does. Maybe it does. What if I change this? What if I made those optimizations I just said, and I just made it so that every player has its own scan map, or every entity has its own scan map? That's a decent amount of data. Not a huge amount, though. Not too bad. If we give every player its own scan map, then what that means is that scan map is automatically cached until you call this function again. Are you going to do scan map and then intersect with entity positions? This scan function does give you entity, like this does give you that already. Because it gives you all the agents that are within a Chebyshev square around you. So, Will, what we were doing before is I was looking at this. I found there is a way to do a really hyper-efficient chunk system that would then scale to like... It would let you scale to much larger vision ranges. And it would let you scale to much larger vision ranges is the main thing. And it would be really snazzy. but I think it would be like multiple days of work, and it would be the type of thing that I would probably have to build in like C or C++ native because it's got memory allocations. Maybe I could Cythonize it, but it would have to be like a standalone module that's perf tested alone and then integrated into this as like an engine add-on. It's not simple. It's just a chunking system, but it has to be an ultra high performance chunking system. Like you need a data structure that has O of 1 everything, and the constant factor on that matters a lot. So it's a little bit rough. But what I was kind of looking at is I think that the easier way to hit 1,000,000 steps per second right now, we can hit 1,000,000 steps per second per core right now if I think all I have to do is there are a couple obvious optimizations on this that'll get me like 5-10% more out of this function. And then I think all I have to do is if I make it so that every player has their own cache of scanning, then I make them call this scan AoE function. Like the creeps can call this once per second instead of 5 times per second. And that is 80% reduction in the bottleneck step. It should be at least like a 2x performance gain overall. And then that gives me my 1,000,000 SPS single thread without even doing anything else. And that's actually what Dota does, I'm pretty sure. The Dota creeps don't scan every frame. They scan like once per second for targeting purposes. So I'm pretty sure that will just do it for us. Why does the step function say 4 seconds total time? Oh, that's fine, yeah. So we're at 189,000 steps per second right now. The step function looks super slow, but I think that this is just function call overhead. Because it's just calling shit tons of internal functions. Because this has been lower ratio before. The creep AI and neutral AI are dominated by, which are the main sources. These are dominated by the scan AoE function. So I think if I just make the scan AoE function 5x faster by caching 80% of it, I think we just get this to like, say 400 or 500K. And this is on my local desktop, which is at least, or at most twice as, half the speed of the other one, of the main machine. So that's what we're going to do. We're going to make those optimizations, and we're going to get our 1,000,000 steps per second, and then we're going to move on to the initial RL stuff. There's one additional optimization that we're going to have to make, which is actually going to, funny enough, make this be much faster. And maybe this will even be more impactful than all the stuff I'm doing now. But we're going to do multi-environment vectorization. Maybe not initially, we'll decide. But we're going to make it so that like you can batch run lots of different environments without going back to Python. We're going to batch in Python. Yeah. Between those two, we definitely get over 1,000,000 SPS. Okay. I'm going to go make my shake. That'll take me, I don't know, 3 or 5 minutes. We're going to come back. We're going to get our 1,000,000 steps per second. We're going to pass go. We're going to collect $200. And then we are going to hopefully have a bit of time to start on the RL today. I'll be right back. Oh, yeah. Okay. Cheers. Ooh. Let's go claim our 1,000,000 steps per second. So what we're going to do for this is not going to be that hard. Really not going to be that hard. Let me fix the AC real quick as well. One sec. It's always trying to freeze me. Okay. So we need to find the data structure that we're using, which is scanned targets right here. So we have this as a 200 length struct. Do max scanned. Can't assign this here, can you? Yeah, we can't do that. We have to do max scan targets is going to be up here, I think. Let's just do it as a CDEF. It's vision times we can save a little bit of memory here, so it's 11 times 11, 121. I think technically for algorithms it's... Yeah, this is fine. This works. And then what we're going to do is we're just going to do, and where is it? Oh, I don't initialize it, do I? I should. Scanned targets. This gets initialized somewhere, doesn't it? Self.scan targets. Huh? Oh no, of course it doesn't get initialized because it's not a 2D array. Okay, that's fine. So we need max entities and max scan targets. We're gonna make this 256 for now. And then we're just gonna add a little assert in to just catch ourselves for when we inevitably forget this and out of bounds this, because this is one of those janky non-checked C arrays. So what we're going to do is we're going to assert num agents plus, this has got to be less than equal to max entities. And then it's going to be self.obsize times self.obsize has got to be less than max scanned. Okay? So now, with the scan targets, we just have to update this function to scan by PID. And entities do have a PID associated with them, so as long as I've remembered to set it correctly, which hopefully I have, we will see. Let me just check. Yeah, towers got PID. Spawn neutral got a PID. Spawn creep has a PID, and then obviously I know the players have a PID. Perfect. So this actually sets us up very nice. So scan. What we're gonna do we just need int PID, player.pid, and this is actually PID IDX is equal to target. This is PID IDX, and that's it. Now, wherever we use wherever we use the scan targets, of course we have to update this as well. PID equal player.pid. Target equals scan target, PID IDX. Scanned targets. We just have to update this everywhere we use it. PID, player.pid, PID. And right here, PID, PID. This is also inefficient. We should cache this. Target is scan target, and then if target break, and that's a little better. Scan targets. And that's it. I think these are the, oh, right here. We missed one. We do target. Target is equal to null. So let's see if we broke anything. This is a big change. We broke lots of things, of course. Cannot convert Python object 886. Push player target. Oh, that's weird. We do well, this is, I guess we just copied this or something because this doesn't make any sense. Yeah, so we do entity start target. We don't need dist. Expid. This is good. Does that do it? Invalid index type. Oh, right. This is not the... Can I make this a memory view? I can't make this a memory view, right? No, I can't. It's obnoxious. I can make a 2D entity array though, right? Let me see. Not allowed. Wait, not allowed in a constant expression. Array dimension not integer. Incomplete. Well, let's make sure I'm allowed to do this first then. Max entities, max scan targets. This looks correct to me. Maybe you're not allowed to do this because it's not like a constant or something. Can I do like a pound define? Nope. Well, that's fine. We'll just hard code max. Max entities, max scan targets. I don't know, can you initialize stuff here like this? Guess we'll find out. Cannot assign. Oh. Hold on. I'm just getting array syntax confused. I believe it's... This is the syntax, right? Does that get rid of one bug? Yes, it does. So let's see now if I go back. Maybe I'm allowed to use this. I should be able to, right? Unless it's like, hey, this isn't a constant. What if I do constant? I don't know if it ignores it or not. We'll see. Max entities, max scan targets. Okay, we can do it. We just don't need the const. Which is fine. Const correct code is stupid. Anyways. Ooh, not allowed in a constant expression. What's wrong with this? I guess we are not allowed to do it after all, huh? That sucks. So we were right the first time. I think it's because you don't have constants and like pound defines that you're not allowed to do this because it doesn't know that this is gonna not, it doesn't know that this is a constant at compile time, right? So it's like, hey, this shit might change. So I think we're like, you can't even, this, I think you just put a comment here, max. This is like 256, 121, right? And then you just hope that this, you can't even do these asserts. You just hope you don't screw it up. Actually, there is one thing we can do. We can at least give ourselves so this is real dumb, but it gives us the same don't shoot ourselves in the foot protection. Now we rebuild. And perfect. All we have are index errors. I do wonder if we should alias. I actually don't know how that works, if you can pass arrays. We're going to just swap the syntax like this for now, and if it's really slow, we'll change it. It should not be really slow, though. Let's see if this actually runs now, or a perf test. It should be same speed, but you never know. Yeah, same speed. Pretty much spot on same speed. So now the thing is, the reason we just did that is so we can cache, right? Let me figure out, well, there's one other optimization we can do first that's a little easier, so let's do that. Here it is. So what we're going to do, this is no longer going to be y and x. Player y. This is player x. Right? And what we're going to do is now we're going to do int y, x. It's now y, this is x. This is player y minus radius, player y plus radius, player x minus radius, like this. Now this PID map doesn't have to do any math on the index, which is very nice. We also move this target type down to here because we don't need it. Exclude friendly before exclude hostile. The most commonly excluded type, I believe, is it's the creep targeting. Creeps don't target neutrals. And neutrals don't target each other. So I think that this is fine either way. And then we do scanned targets. Perfect. Return IDX greater than 0. So this should be the exact same thing. It may or may not make a performance difference. This is a very small optimization, but this is the most performance critical piece of code in the entire project, so it is possible. It is faster than before, but it's potentially within the noise. I mean, it's definitely faster. We don't know by how much, if it's substantial or not, but who cares? We have it as fast as it can reasonably be now. And the only thing we have left to do is implement the caching. So let's do that. Scan AoE. And how do we do this found target thing? So what you do is you go through scan targets PID is equal to null. So this actually doesn't even have to return anything, because it sets this null right here. Like this. So there are like a few places where we call this scan AoE. Let's start with the creep AI. Okay, so we scan AoE. And then we do if self.scanned is not equal to null. 0. Int PID. Creep.PID. Now there's some follow-up logic we're going to probably have to do once we implement this, because the caching is going to make a few things a little bit weird. But do we have self.tick anywhere? Yeah, we do have self.tick. If self.tick %5 is equal to 0, we scan. And that's literally it. Well, now let's do the neutral one. Player AoE attack can still have a updated scan. AoE push can have enough. These are all simple. I think the towers can even have well, it's probably kind of slow, right? We'll do like every 3 ticks for the tower. In 0.6 seconds. It's a little faster. This fast enough. And then this is the last place right here. Let's see if it works. We forgot to define. Forgot to define PID. PID. We actually don't need found target. Creep AI. We probably don't need it in creep AI either, right? Is there a found target? Nope, guess not. So if this works, this is the last piece of the puzzle, I think, to get us the perf we need. So we get moba perf.py. Not as big as a as an increase as I would have thought. But now actually, like, almost this, so much of this time is in the step function that you almost don't know. I think we should, here, we should compile this without without C profile on, or without what is it? We should compile this without profile directive on. Because I still don't know how much overhead the function calls are. So Python profile false, right? There's still some stuff that we probably need to be caching in the attack functions. Let's see how close we are, though. Oh, we're there. We win. Cool. That's... Well, let's see if this actually... Hold on. Before I say we're there... Oh, look. It's the exact same game. We didn't break anything. That's amazing. At least nothing critical. It looks the exact same. Okay, so there you have it, guys. This is 680,000 steps per second. We started today at 70,000. So we got a 10x improvement. And as I've said several times, this is my local desktop here, which is an old machine. The puffer boxes, which are the target hardware, which is just a higher end desktop, those cores are at least twice as fast. So this is well over 1 million steps per second. And mind you, this is with, where is it? Well, you can't even see the total amount of overhead because it's not showing you. But this is a low-end estimate as well, because we're also going to vectorize this so we can do multiple copies of the environment at this on the same Python process. So that's going to bump this up a whole bunch as well. So there you go. We hit it. 10x perf improvement in a day. I think that's pretty good. That's pretty good progress. Could it be faster? Yeah, it could be faster. It could definitely be faster. But this is going to allow us to do pretty much everything we need. Yeah, they're going to be allow us to do pretty much everything we need. So it's a little bit awkward for the reinforcement learning side at the moment, because I do kind of need to write that binding, don't I? I do kind of need to write the binding for that. Like, you're not really going to be able to do RL until I have the multiprocess, not the multiprocess, multiple environments per Python process, because right now there's a 250 some odd megabyte map that needs to be shared, and if you don't share it properly, if you just like make a bunch of different processes and all load it up, then it's going to be way too slow. 256, 258, I don't know what it was, megabyte pathing data. I'm going to commit this for now, though. And we're going to run it on, maybe we'll run it on one of the bigger boxes just for fun. Want this data file. Want this MOBA file. Want this pre-computation file. And we want the setup file. Anything else? Looks like that's it. Oh, do we want this MOBA perf file? Maybe just for now. 5 hours or so of work. Set up, build. Come on. This is just weird. We had this before. This is just weird pip shenanigans. I think you just have to run these a couple times until it... I don't know, it's weird. How about now? How about now? You can see it's building something even though I just built it because it's taking that long. Bizarre. It was literally what I did last time and it worked. Is dumb. Okay, what the hell? Is there a file missing here? There is an underscore init that I forgot to commit. I think that's what it was just the init file. I don't know if it was the pip install or the build that made it work, though. Obviously, these are things that will be worked out before release. But this is the type of boring thing where if I were to get it, understand exactly what's happening now, I'd be scratching my head for 3 hours. There we go. It was just the init file. Let me just make sure this is correct. Multiply, and it should be multiplied by 10, right? Number of ticks times 10 because there are 10 agents. Right? This can obviously shift by a reasonable factor depending on what's going on in the game, but I think as an initial perf test, we are set. 34 million function calls. Cool. Oops. Let us post. Thank you. Stars much appreciated. This is so stupid how the internet works. This stupid post of mine has 1,000 likes on it. 32,000 views. So ridiculous how that works. And it doesn't get you in, like, it doesn't convert anything. It's just like, congratulations on your internet points. You made a funny joke. All right. Do I post the GIF again, or do I just post the perf screenshot? I probably post the GIF again, right, even though it's repetitive. I think you have to re-export a GIF, though, so that it gives you a different... It doesn't record you as, like, posting the same media or whatever. Let's do that real quick. And then we actually will get to do the multi environment thing that I was talking about, and then we get to do a little RL, just a little bit today. I said Thursday at the latest. We'll get to start it, Wednesday evening. That's on track. Gives us all day tomorrow to work out good policy stuff. Obviously, we're not going to have like the game being solved immediately, but oh, hello there. I didn't see your message because the thing was... Oh, no, that's just Will. That was from earlier. This thing covers the transparent... Transparent UI. I think we screwed up here as well. Hold on. What? I hate the Windows thing that just like, yeah, let me minimize all your stuff. Hold on, where did everything go? Here, this is fine. Okay. Right, we needed this. We need this is self.outcome. Now it should work. It needs to just be able to know when the game's over. And we should see this. Takes like 14,000 steps. Uh-oh, is it behaving differently? We getting... No. Radiant just took tier 3. Dire took tier 3 as well. Dire just took tier 4. Radiant has taken tier 4. It's a very close game. Long game as well. And there you go. That looks like Radiant victory. Radiant victory. Docker, Dire victory. So this is actually Radiant victory. Right. single thread. Where is it? Where'd my file go? That's pretty cool. It's actually Radiant Victory. There we go. How much data is that? Gigabyte a second, I'd say. That's better this way. That's nice. Okay, so that's fun. I promised 1 million steps per second. I delivered 1 million steps per second. Now it's mostly just what can we train with this, and a few more integrations. We obviously, like, there's a whole bunch of stuff that's not fully implemented in the game that we're gonna have to do, but this is kind of enough to get started. It's pretty stable. I think that there's even with this, like, there's probably some cool stuff the agents could learn, right? Now, whether they're smart enough to learn it, who knows? They kind of actually have to at least go down the lane. But probably if you give them some, like, really basic objective function, like if you just give them a reward for getting to the enemy tower or the enemy fountain, they'll probably learn to do something, right? With this much data. Yeah, they'll learn to do something cool. I have no idea how cool, but it'll be fun. Okay. So, the one other thing that we have to figure out how to do here, which is it non-trivial? No, it's pretty trivial. We just have to figure out how to run these things in a loop, basically. I did this in, I think I did this in Snake, didn't I? Or in the continuous grid. C grid. Oops. Oh, did I not do it here? Maybe I did it in Snake. Yeah, right here. So I have this step all function that takes a list of M's. Yeah, okay, I remember. So this is actually pretty easy. So what you do is you just make a list of these environments on the Python side. And this isn't perfectly Python. It's not perfect, but it's better than vanilla for calling steps in a loop by a substantial margin. And it'll still break up a little bit of call overhead. And I think the main thing was the way I was splitting up actions, right? Step, where is it? Get ems.step. Oh no, it was the way that I was populating the action vectors, I believe. So if you look at like Snake here, if you look at the call, it's kind of clever how it works. So you get this pointer through end like this. And this is why I always point people to the Snake example. It has everything. So you have a pointer and you have the end, and you're just giving each environment a slice into this buffer, but this slice is a memory view. So you basically just have everything in one giant tensor, and then you just give different slices to different sub-environments. And that means that when you populate, you vectorize, populate all your data in NumPy on the Python side, it's immediately updated for all the Python M's. So that's pretty cool. Yeah, let's do this. I actually kind of want to leave this up as a reference for myself somewhere here. Here we go. Oh yeah, we also have to handle resets fast, because I just straight up didn't do that. That's almost more important, but we'll get to it. I want to get to some RL. Alright, what did we do here? Like num-ems? Yeah. We gave a lot of parameters for this one. DoTA is actually simpler in this sense because it's like not procedural, it's fixed. Num-ems equals, I don't know, 4m's. Okay. Num-ems is num-ems like this. And how do we do it? Do we make the buffer flat? Yeah, we made it flat and gave slices. Why did we do that again? Do I remember why I did that? I did it because it makes sense with the observation spaces to do it that way, so you may as well do everything that way. It does make it slightly more awkward to do some stuff, but I think it's fine. Not really, is it? Oh no, I remember why I did it that way. The reason I did it in the Snake doesn't apply here. We're fine. We can do this more reasonably. So, we get the game map. We get the grid. We get PIDs like this. I think this grid has to be a copy, doesn't it? Yeah, this grid totally has to be a copy. Remind me to do that. PIDs is going to be zeros. We add num m's to this. C entities. Okay. C obs players, self.num m's, comma, then observations. We can get total agents here, right? Num agents times. I think this is actually has to be like this. Num is 10. Yeah, this is 10. It's always 10. Num agents is correct. Correct. It's correct. And we don't use this. Okay, now we get to the interesting part here. CMs. Okay. CMs. Like so. And we do for I in range num envs. We need pointer. We actually don't need pointer because we did it way easier this time, didn't we? So it's going to be I, comma, dot reshape num agents ob size. Wait, that's weird, isn't it? Oh, no, it's not. This is we had it right, but it's lower down. So this goes down here. This goes down here, right? This is colon. Observations. What is observations? Buff observations. Num agents. Nope, this is correct over here. So I am just doing like various like little tiny annoying bits of tensor manipulation in my head. They're kind of hard to explain, but they're very basic. I'm figuring out if data needs to be 3-dimensional tensors or 2-dimensional tensors, and the difference would be that the 3-dimensional tensors have number of environments, comma, number of agents, comma, whatever, and the 2-dimensional ones are just going to be like num agents times number environments, so you roll them together. That's all. Yes, we got self.agents, we've got entities, self.entities. Which we did obs players. We did num m's. Wait, what? No, we're fine. We're fine. So this is self.grid.copy. This needs a copy. Self.ai paths. This is not a copy. It doesn't get modified. It's immutable. Well, not really immutable, but be nice. This gets I. Okay. So you append. Self.c entities I. Entity data is shared. Obs players is not shared. Obs view. Ugh. Maybe this. You know, it's still you end up having to slice anyways because these rewards and stuff are flat. I think it's probably better to just do everything flat, huh? It's really obnoxious because otherwise you have to have a whole bunch of different views. Yeah. Yeah. Okay. We'll do it that way. I'm losing a bit of steam here, but I want to at least get this to work. I want to have it so that we can run multiple environments without blowing up memory. Though actually I do recall memory blowing up anyways, but we're going to see about this. If we don't do this, we definitely blow up memory because we don't share the pathing maps, and the pathing map is 200 some odd megs, and we're going to need like 100 of these environments. More, 400 of these environments per core. We're probably going to be running like 800 some odd environments, so that's a lot of memory. 800 copies of DoTA is pretty fun. Did they actually tell you in OpenAI 5 how many copies of DoTA they ran? Was it one per core? I don't think they told you how many copies. But if they were using 128,000 cores, are they running the game single-threaded? I would assume the game just runs single-threaded, doesn't it? Well, actually, no, the game shouldn't run single-threaded, right? But still, they're running like... They're probably running tens of thousands of copies of the game, at least. I could ask him that. Oh, they also give you that they have 20,000 numbers. So that's like 80 KB observations, which is big. So give you their observation size. They have a lot of data. They're pushing lots and lots of data. A crazy project. This PID map is fine like this. Actually, what am I talking about? This is all fine. I literally, all I have to do is compute some pointers. It's literally just 10. There's 10 each. Agents. Obs view. That's it, I guess. Creeps. This num agents is wrong. This is gonna be 10. Neutrals, towers, vision, whatever. This is fine. It's fine. You reset this. Turn buff observations. And what's this step thing? We'll do the step in Python to start. We'll save a little bit when we oops, when we move it to Python. You need pointer. Do you need pointer here? Well, this is the big spot you're losing a lot as well. We're going to do it this way for now, but there's an optimization here. N plus equals 10. Okay, so you just do like this. Pointer colon end. Okay. This is fine. And I think the render just takes the first one, right? Self.client.render grid. Oh, but because you're giving it a copy, this is going to be kind of awkward, right? Here, we're going to do if I 0 grid equal so like render env gets true grid, render env gets true grid. Otherwise, the grid gets updated in place, and you can't have all the environments updating the same env, but you'll just give it this grid. This is maybe fine. Yeah. Okay. And then when you do render, let me see, where's render? Self.client render grid PIDs 0 0 0 star 10. This is probably going to take a second to get correct, I'm assuming, right? But basically, as soon as this works, oh yeah, we didn't change that. Demo env mode eval remote waylib. As soon as this works, we're pretty much set. We have to still do fast resets, but other than that, that's pretty much like complete loop. Argument zeros. Right, so we have to add some parentheses here. Num environments. It's probably numems, right? Okay. Appears to work. Do we do a perf test again? I think it's probably about the same. But we'll do a perf test before and after we add the step function in, I guess. We have to pass numems here, don't we? We'll do 10 ems. Okay, and then we'll pass, is it 10 time We'll just do numems like this. Ten environments. We'll see if this gives us something that makes sense or not. We're expecting it to be the same as before, roughly. Maybe a little faster. We haven't really done the optimizations that let you take advantage of this. Yeah, same speed. Same speed. There's some optimizations we can make, of course. Let's make a very small one right now. This is environment. Okay. And then def. And all we do is... Oh, I haven't implemented this action thingy yet. How obnoxious is that? It's gonna take me like 5 minutes. It's not that hard. I'm just tired. Let's just do it. It's not that hard. Actions. All we have to do, so this is a fun trick. You just cheat your actions into the environment as a memcopied buffer. So we have rewards, about self.buff.actions, pointer through end. Right. So all we just did is we just cheated the actions in here. And now all we have to do is it buff actions or actions? Hold on. Self.actions. Yeah. It's just self.actions. These are separate. And then when you do step, this is pretty cool. Actions. And then, because you've cheated actions in, you don't have to pass them as an argument anymore, so there's no data transfer there. It's just in place. And then you just do step all, self.cms. You comment this because this thing does not need it. You don't need this anymore. You edit cmoba words, because we have to add float actions here. Float actions like this. CNP. Bad suggestion there. CNP.nd array. Rewards. Okay, so now we get rewards. Nope, not rewards. That's what we had before. Actions. Rewards. Now we have self.actions equal to actions. Very nice, right? Now we can right, we no longer need step. Step. This is kind of cool actually because step, or is it b int? What the hell is this function? Yeah, this is allowed to stay at BN, but this is kind of cool because what this lets you do, this was a CP-def before, right? Which means this calls back to Python when you call it. This is now a CDEF that takes no arguments. So now you have this def function that's Python, but it's really fast because this is this loop here. Oh, how did I mess this up? I'm gonna type this index. Pi. Yeah, there we go. NumPy actions. Oh, this is actually even funnier. So this is self.actions here. There's going to be an opportunity to make this even faster. Memory view. Right. This is actually a 2D array. The actions are two-dimensional. No big deal. Float. Unsigned int. Self.actions. We have discretize on right now, don't we, or don't we? Do we or don't we? I think we have it not right now. We'll have to figure this out, but I think it's like this, right? Actions continuous. Pi list get item. Yeah, we need this from C snake, or was it? What we have this in? Snake, C snake. This import. Solid. Well, we got that. Now, let's see, does it... Probably not a huge performance difference. Ooh, expected float got unsigned integer. That's not good. Expected float got unsigned integer. This is float 32, I believe. Actions. Input array from shape 10.6 into shape 103. Well, hold on. Some shenanigans. This is definitely supposed to be a 6. And why is it only 10? Should be num agents, right? 10 times num then, self.agents. This ought to be... This actions tensor should be bigger. This actions tensor should be bigger. Self.agents. Agents. self dot. Okay, this is weird. This looks good, but for some reason we don't have the right number of agents being registered. Agents seems to be good. What is it that makes this pick up the number of agents? I would think it would just be dot agents, right? And you do agents per env. Yeah, it's num agents. Self.envs. So this num agents should be correct. I'm just trying to figure out why it's not registering that I have 10 environments correctly when I'm passing to the neural net. Oh, it is registering. I'm just dumb here. How much memory does this take up? Okay. That's up a little bit, right? That's a little bit of performance. We're now at 700K, right? And I'm going to risk running 100. If my computer explodes, see you when I get a new one. It's actually nice and memory performant. That was stable. I guess it's the renderer that has a weird leak in it. Funny that that decreases steps per second, though. Assumedly, it's just like different parts in the game or whatever. We'll leave it at 10. Don't worry, we'll have consistent 1 million because we have a few additional like vector optimizations we can make along the way. So the 1.3 million I posted, it'll be a nice consistent at least 1 million. There you go. There's your 709K with 10 environments. So 100 agents. And like, I don't know, 2,000 minions or whatever. And the 700K, remember, it gets more than doubled on the other box. So that's like 1.5 million now, probably 1.4 at least. Okay, so there we go. There's our Vec implementation. Multi-env, I guess you'd call it. Perf. And, MOBA optimized for multiple perf. So this is technically enough that I could start on the network, or I could make the reset function be more reasonable. I kind of want to start on the network design. Just a little bit. Because it's kind of tricky. At least it's going to be tricky to do well. Let me see what perf Clemens said he got. So Clemens has this real cool blog where he does this entity neural networks. 100,000 steps per second on a single GPU. I'm going to assume that I have a better GPU, so let's say I get 200,000, but that's still too slow. This is a criminally underrated project, by the way. I thought this was way bigger. He kind of just quietly released this with one blog post and didn't promote it too much. This is like an awesome, awesome project. Why the hell don't I have this starred? Just give him a star. Main one, at least. Oh, this is so funny. I forgot that he did Snake as well. I should message him on this. He didn't document this. It doesn't think it has a nice renderer on it. Oh, but his env is in Python. Isn't it? Yeah, he did all this like efficient stuff, but then the env logic is in Python. I should tell him. He'll be happy. This was like a cool demo as well. I should chat with him about this stuff. He's around in SF, I know. He does like really high perf engineering on this side. What I'm basically just trying to figure out is if his neural network architecture is remotely reasonable for the level of perf I'm going for. He's got this ragged attention thing, which I don't need it to be ragged. I just need attention. I don't know if he did multi-headed attention or if he just did attention either. Oh, it is a multi-headed attention. So he said he has a ProcGen experiment thing as well. This is his RogueNet architecture. By attention, I think he means multi-headed attention, because he mentions it before. Let me see. Matrices projecting each feature. So these are really small. So he's using like 10,000 parameters. But the thing is, if you're only getting 100,000 steps per second with 10,000 parameters, like our implementation on the Snake environment is way faster than this. Because on our Snake env, we have 150K and we get 1,000,000 steps per second. I should definitely catch up with Clemens, though. He does really awesome work. And before I, the engineering I was doing was, like, relatively low perf by comparison. But now with the latest stuff, it's actually, like, really fast. And, I can play ball with these numbers with the latest sim stuff, which is real cool. It's really cool. Version of Impala used in ProcGen. Okay, so this is them using, this is them, like, doing some comparisons, okay. I still don't know if this attention block is reasonable. Because if this attention block is limiting you to 100k FPS with that little data, then I'm pretty sure that you're just straight up not going to be able to use it in R setting. It scales quadratically, and quadratic among, yeah, you can't do like, well, if you had like 20 entities, 20 by 20 is 400, 400 times 32. I think that's already too big. Oh. I forgot that he credited me for the review. I did not contribute very much to this whatsoever. This was really his project. He did awesome work with this. But this list of like reviewers is awesome. Chris Bamford's awesome. Costa's awesome. This is a really cracked project. I remember telling him I wasn't sure about the hand-drawn, like the hand-drawn style like this, but I was totally wrong. This is awesome. Well, this kind of tells us this kind of tells us, though, right, that we're not going to be able to do this. So let's look at the DoTA architecture for other inspiration. If it's not clear, the point of what I'm doing now is I'm looking for like feasible architectures for this thing. I can draw it out. Maybe that'll help me, and that'll be interesting. There are a couple people still watching this, so I'll draw it out. Not this one. This one sucks. Sketchpad. So the way that you look at this, you have 2D map data. Okay, you have 2D map data that you get. This is like if you are here, if you're here, you're like this agent. Whoops. What the heck? That's weird. Why would you ever want... Let's just refresh this page. Oh, geez, it saves it? Okay. So you have this type of a thing here. This is like your vision. And you have your... I drew it like an even size. It should be an odd size. But let's say you have your agent like here, right? And then you have like some walls here, right? And like maybe you have a wall here. Okay, so you get like your terrain map, and maybe you have orange. Maybe you have like another agent over here that you can see, right? So this just gets interpreted as one hot. So this gets... So this basically like... Say this becomes 0, this becomes 1, or more likely this becomes, here, this becomes 1, this becomes 2, and like this becomes 3. Okay? And then you put this into your convnet, which I'm going to attempt to draw like this. Right? This is a convnet, kind of. And then you get this into a flat vector. And then the architecture for this is that you put this into an LSTM, and then you put this into an action head. This is your classic architecture. This is what I use on Snake. It runs 1,000,000 steps per second, as long as you use small convs. But the thing is with this project, the thing that's difficult is you also get these like entity vectors. So this is like map, and this is entity. Right? And this is the thing I need an architecture for. And this is hard because like this is set data, and it's kind of a lot of set data. We're going to assume this is like 20x20 maybe. Mixed, discrete, and continuous, though we might be able to sidestep that. So this is 400. This is almost already too big just looking at this. Though we can probably limit this to be like, if we limit this to be bytes, it's not that bad. If this is like 20 by 20 bytes, that's not terrible. Though if we're making this float data, maybe if it's FP16 data, it's okay. It's kind of a lot. We're going to have to figure some stuff out. We're also going to have to think about like what you get from these entities that you can't get normally. You know, it's possible that we could just encode all this shit into the map. That might be better. Let's look at some architectures to see if we have some reasonable way. So basically, it's just like you have a bunch of different agents around you, right, that have different properties. And that's a lot of data to encode. So the two different options I have are try to stick this into the map somehow, which I have ways of doing. It's not impossible. And I even have ways to compress that data if I need to. Though it is kind of continuous data, which is a little wonk. But that's one option. It's a little awkward to do it that way because then you still have to like, you have to output a target on the map, which is hard. Maybe it's not that hard. It might not be that hard, honestly. You have to do like a deconf. The thing is, the entity-based architecture is just really cool. And it's a really nice opportunity to do it. But I don't know how fast it'll be. Let me look at OpenAI 5. This image. Let me just fix the heat real quick. We might even want to just time some different architectures, you know? Okay, so this is the hard thing right here. You see how they have unit 1 through n? I guess you can't see this on the screen here. So this is here, this is unit 1 through n. They've got like a big stack of units. Same thing as we have. They've got a really fancy encoder, but ignore it. This is just like an MLP, basically. You have all these different units, and you need to pick one. So again, they have fancy architecture, yada yada, it doesn't matter. The key thing is that you eventually get an embedding for each of these. So if they're like 20 units, you're going to get 20 32-dimensional vectors or something. And then you have these as unit attention keys. You dot product them with the output of an LSTM, and then you use this for targeting. It's a pretty reasonable way of doing targeting, to be honest. I don't know if it's the best way. at least for the small scale stuff. The thing that's really obnoxious about entity data like this is like you can kind of do everything with 2D maps, right? Like if you think about it, the thing that I just drew, I can kind of do everything with 2D maps. Like if I just output a 2D map of like, hey, these are where I want to attack, then I don't have to even think about this information. But the thing is, the reverse is not true. I can't just do everything in terms of entity data because you still need the freaking 2D map. Because you need to know that you're not pathing into obstacles. You need to know the terrain. So it's essentially like either do everything in 2D map and try to make that as good as possible, or you have to split it and now you have two things to optimize. And optimizing the entity one is not easy. Because like there's an existing architecture that works perfectly for this. It's a transformer, but it's too big. I mean, the fact that like image gen models exist, like DC-GAN, generative image models, even the really early ones, that kind of tells me that it's reasonable to do map data in, map data out, right? So the architecture I'm imagining now is you have an input that's like a big stack of channels. It's like a very many-channeled image, where like some of the channels are map data, but the other channels are for entity data. And you get it to be like some reasonable number. Maybe you compress it, right? Whatever. You do whatever you need to do there. But the idea is like at the end of the day, you're going to end up with some reasonable number of channels of data. It's all one data type. It's just like a 3D thing, 3D block of numbers. You do like a conv layer. You do like one or two conv layers in a fully connected. You put it through your LSTM. And then the decoder head is going to be the opposite. So the decoder head will do hidden dimension projected into this. There are a lot of basic architectures you could use for this, actually, now that I'm thinking about it. You could even do like one by one comms or whatever. That's essentially an entity network. It's probably pretty fast as well. Yeah. I think we need to probably code up one of these little architectures, though, and see how fast it is, don't we? I've got an hour. That'd probably be kind of fun to watch, right? We code up, we're not going to integrate it or anything, but, like, we can code up a little test architecture just to see how reasonable it is. And, like, if this thing runs 1,000,000 steps per second, then all we have to do is optimize the rest of the data pipeline and it'll train at 1,000,000 steps per second or whatever. I mean, I guess we have to, like, estimate the train versus the forward pass and stuff, but it's pretty reasonable overall. How could this screw up? Well, the one way that I see if this screws up is, like, the action space is really big, right? Yeah, your action space is like 120 something dimensional. Well, that's like a discrete of 121. It's kind of rough, isn't it? But like, if you do an entity-based one, and you say like, let's say you limit it to 20 nearby targets, you have a discrete of 20. You don't get any positional awareness. You have to learn it. I think we try it. I think we try it. I mean, is there anything else we could do? The other thing we could do that would be way jank, but would let us actually get something working initially. And this is probably where we should start, to be honest, though it's a lot less fun. Is, let's say we just load up all the data that we want into this this image format, right? We prepare all the data, we make a reasonable network, and then we just totally punt on targeting, right? We just like script which agent you're going to hit, and then we let the agents learn. They learn the movement, they learn their button presses, right? That'd probably be way easier to get started with. In terms of scope here, like, I bet you if I go that route, I can have something training on somewhat reasonable data at somewhat reasonable perf by the end of the day tomorrow, if I go that route. Whereas if I do this, this is like uncharted territory. And the thing is, if I do the safe version of this, I have a pretty darn easy way to like try to expand. Because like, yeah, there's no world in which it's pretty much in every possible case, doing the first one makes the second one easier, and doing the second one first is like really, really, really hard. Okay, so let's try this. Let's just try it this way. Let's figure out how we're gonna mess with all this map data. It's a pretty safe format as well. It keeps the network architectures very uniform. Yeah. I mean, technically all we need is the map data to start with, right? Yeah. We just need the map data to start with, technically. All right. Let's see what bullshit we have in here that we can adjust. Observations. What is this? Oh, this is kind of fine. This function is slow. So what we're going to do is we're going to want to do this in C. Yeah, we're going to want to do this in C. That's pretty easy to do, isn't it? Don't I have like a slice of this somewhere? Buff.observations. Yeah, so right here, you can see this is self.obsize plus 3, right? So it's actually pretty easy for me to know how to structure this. C obs player, C obs view. Self.obs view. Let's do this is map obs view map. Obs view extra. Oh, this was fine, right? Obs size times obs size onward. And we'll do obs view of I. Oh, is this I correct? Wait, obs view. Yeah, this is fine. So obs view I. Obs view extra of I. This is self dot. Okay. So this here is unsigned char observations. This is actually going to be map observations, or observations map, and then unsigned char observations extra. Map, and then CNP array words. And we'll leave this hanging. Now let's fix it. There we go. So this is observations map extra self observations. I think this is the only place we use it, right? Map. Okay, and then we do self.observations extra hid 0 player.x, and this is a uint. This is a uint here, which is fine because the player position can only go from char. I think I can do this maybe? No. I think I can do this. Reward. So we'll do player.reward. Do we do player.reward? Or we do rewards of PID. Self.rewards of PID. That's probably good, right? I think this is a decent architecture. We have ability to add stuff here. We have a 2D map. Basic starter architecture. Right? Super basic. Let's see if it compiles. It's pretty nice. Okay, so far so good. Okay, so we have a few little bugs, it looks like. Cannot reshape array of size 30. into 1, 10, and 11. Let's see what the heck is happening here. Yeah. Oh, I know what's happening. That's fine. That's dumb. This is like 3, right? Other way around. Right here, this one's 3. Bada bing, bada boom. This works. Let's get, well, the network is actually probably kind of like minutes away from being valid with this, frankly. We'll add the config for it. Config slash vim moba current, and we'll just like go add us a moba. We'll go add us like a moba thingy, which is it going to be like the grid one? It's probably going to be pretty darn close to the grid one, right? And then, hold on. There are 8 different things. So the grid policy, it's very, very, very similar to grid policy. We've got 8 different channels on an init. And then it gets flattened. There's a proj. $32 plus. Yeah, here's your flat right here. There's the continuous bullshit. Here are your features, Divide by 2. Yep, this is identical. So pretty much an identical architecture. There's one thing right here. The 7 has to be changed for an 8. No big deal. Otherwise, literally identical architecture until we start messing with it. We should probably actually try to make this run just to see. Oh, we should also adjust the we should adjust the batch size and shit to not be like insane. We'll do like 1,000. 100 maybe. I'll mess with the BPT horizon. Oh, we'll do like 1,000 and 10,000 maybe. That's reasonable. Yeah, that's fine. And num ems, num workers. Probably good. $157K is what we expect. It just works first try. That's so funny. That's so funny. Okay. So this thing just like, it works. The main thing is that we don't have a way to reset the environment now. So we need a way for the environment to efficiently reset itself. And then as soon as we have that, basically, we can like, well, we can absolutely tune this to be high performance. So we can like tune this to make sure we're getting 1,000,000 steps per second train throughput. And then we get this very, very tight feedback loop where we like design reward function, train model in 3 minutes or whatever, plot on 1B, see if anything happens. log images to 1B. So we're going to have like, it gets old fast when you've been doing it for long enough, but if you haven't seen this type of work before, it's pretty cool because like you get the model to do a lot of cool stuff very quickly, and you fix like dozens and dozens of bugs very, very quickly. So I've got an hour or so. No, I don't have an hour. I've got 40 minutes before I'm gonna go for dinner. So I'm gonna go use the restroom real quick, and then when we come back here, I'm going to make this environment have fast resets. That's a very important simulation design aspect. It's actually probably one of the most common failure cases I see with RL environments out there is people put tons and tons of effort into making their environments fast, and then their resets are like 1,000 times slower or something, and they totally lose all their performance. And then because of the way they do their multiprocessing, they lose even more performance than they should off of that. So we're going to go through that. I'm going to show you how we can not lose perf on reset, and we're going to go from there. So I will be right back, and then we will do that, and that'll set us up very, very nicely for experimental side work tomorrow. Be right back. Okay. Let's close this out with really, really fast resets on this end. Relatively easy to accomplish usually. It's possible I've made some design oversights that are going to make this harder than I expect, but I think it shouldn't be that bad. What are we currently doing reset? We reset a bunch of players, we set some lanes, we call compute observations. Nothing here is hard. Nothing there is hard. In fact, it doesn't even really need to be there. Well, I guess it does. What about init? Where is this? Okay, so the waypoints only need to be calculated once. We don't need to do this again on reset. The towers, everything can be pre-computed for the towers when they're spawned. We just need to make sure that the respawn resets them. We might need to add like a couple attributes for like default or base or something. That's no big deal. Ancients, exact same thing, no big deal. Neutral camps. Same exact. Okay, no big deal. Easy. Easy, easy. The one thing is, do you move on the grid? You do move on the grid, don't you? We have to reset the game board, which is kind of gross. Yeah. So technically, when you spawn stuff in like this, right? This isn't going to be that bad, though, because the games are so long that this is going to be negligible. Yeah, so this move to function. Yeah, we made it so that you move on the grid. I mean, no matter what we do, we'd have to reset a grid. Also, PID map has to be reset. So these two things have to be reset, I guess. That's no big deal, though. Let me, let's go fix this. We just reset, we just have to store the original grid, right? Star rig PID map. And then all we got to do, no, it's not PID map, right? It was a grid. Where's grid? Grid, yeah, here. Rig grid. So we need this because it has the, well, it has the original data. I don't know. Rig grid, grid.copy. Copy the original. Then on reset, spawn tower. This sets like spawn X, spawn Y, right? Spawn tower. Oops. Yeah, so it needs to set spawn X and spawn Y. No big deal, though. They're just like a few variables we basically have to make sure don't get screwed up. That's all this is. Waypoints are fine by default. So it's the spawn tower. Oh, wait, we literally, the way we did neutral spawns here is perfect. We kind of already did this for ourselves. Yeah, we should just do this for towers, right? Do we do it for creeps? I guess we don't do it for creeps. Yeah. Let's just make, so we have this array neutral spawns right here. let's just do tower spawns. Tower spawns. Neutral spawns. And we'll just do towers, right? Tower spawns. And what we'll just do is instead of doing spawn tower here, oh, we need it all the way up here. Yeah, so tower spawns is zeros here. Prefix, suffix, yada yada. And then we do self.tower spawns. IDX 0 is Y and is X. We no longer need to care about the team and the tier. IDX team tier. We do need to make a spawn towers function. And let's just go grab all this code that we're going to need. We're not going to actually use all of this. So IDX team tier. Team tier. Let's just do, oops, tower spawns. We're going to make this 4dim. We're just going to do that this is like YX team tier or whatever. Easy. Spawn all. So this is literally just like cdef int idx equals 0, int idx, and then like for idx in range num towers, spawn tower, like this. That's literally it. Once we've extracted the data, right? Yeah. It's idx team tier. Yeah, it's team IDX team tier. Yeah, this is correct. It's jank, but it's correct, and this will get us in the ball game, whatever, in the ball game. This will get us on the playing field at least for, I don't know, insert dumb thing here. We need this so that we can reset shit fast. That's all there is to it. We no longer need this spawn tower. We do need self.tower team 0 tier 5. We're just treating the ancient as a tier 5. I know it's kind of weird. And then we just do team 1 tier 5. Perfect. Okay, so now we're not actually spawning anything here if you look at it. We're just like setting up a bunch of data. So when we do reset here, we can just do self.grid of everything is equal to the original grid. And then we can do self.pid map of everything is equal to -1, right? And then we can just go through the agents and we just respawn all these players. They get their health, damage, XP, everything gets reset. And I'm sure that we're missing some like variables, so we're gonna have like horrible issues with this, but that should be all we need. So yeah, that should be all we need. What reward do we want to give them? I think we probably want to give them I don't know if XP reward will be enough. Yeah, because they need to go towards the minions in order to get that XP reward, which they're not going to do on their own. That's going to be hard. So we'll give them a reward for going to the other side, and we'll give them a reward for XP. So technically, we should make this a 4-component reward. Where we have this. Compute. A little bit hard to do that. We'll just do a joint reward for now. For both. So, on kill. This needs to be cdef p int 0. P equals. And then what we do is XP. And then we get the player has a reward. So we do player.reward. How much XP do we give them for this? I mean, how much reward do we give per XP? On kill. What's like the max here? We give them a lot. Do we divide by 1,000? You only get 35 for a neutral, though. We probably don't want to just give them 1 for killing something. We'll do XP over 1,000. All right. And we also need to remember to reset at the start of step. Player.reward is 0. It's a big common mistake. Very easy to catch, but common mistake. So we gave them a reward for kill. We actually have to add it to the player struct, right? The float reward. No big deal. And we also have to give them a distance reward, right? So instead of reward equals 0, we do player.reward plus equals or minus equals We need to get like the fountain position, right? It's obnoxious. Reward based on distance to... Oh, distance from your own spawn is interesting. That scales better with the other lanes, doesn't it? Versus just going down mid. A little bit. But then it doesn't drive you to the enemy base. I think we do it. Distance to enemy ancient. So if player.team is 0, ancient should be get tower 23. This is the enemy tower. Player minus... Okay. cdef float dist ancient dist to ancient is going to be the absolute value of this distance. Yeah. Else get 22. And we can just even simplify this. cdef float. And then this is going to be minus equals ancient divided by the maximum is 255 in L1. I think giving a crazy big reward is going to be we're going to do like this. I think a negative 0.1. I think this works. Compute observations. Self.rewards of PID. So let's just make sure that we do self.rewards PID. Yeah, there we go. So that ought to give us something like reward. Now we need to get the summary metrics, I think, working. Because I kind of punted on a lot of the summary metrics. So, yeesh. This is fine. We get rid of this. I don't need this. We still don't need this shit. For now. This is going to be random until we, like, implement proper action stuff. Or it's going to be the scripted thing until we implement proper action stuff. We don't need this reward fill 0. We do it on C side. We don't need self.actions equal actions. We don't have the reset thing, right? Outcome. I think we just auto reset. Reset. Seed equals 0. I don't know. It's not even seeded. Okay. So this is now resetting correctly, I think. And what the hell happened here? Oh, I just have the... What happened to my client? Oh, it just loaded weird. I actually don't know what the hell happened here. Oh, I just commented a bunch of shit. That's fine. Or did I leave? I think I left something half commented maybe. Okay. This is fine. We gotta fix that. Rewards.sum, this is fine. Reward, you get this. Radiant level. Min radiant level. This thing is not gonna help us now. Because it's like flat. I guess this tells us for the first environment, which is fine. So we can leave this for now, I suppose. And this return function is probably needed as well, right? Buff rewards truncations. Yeah, this is fine. Let's see if we can get this thing to report a non-zero reward. Where is this? 1295. CDEF not allowed. Oh yeah, because it's. Let's just define it up top. Who cares? Hopefully my mic is filtering the background noise outside. 365. Cannot assign float to int. Oh. Yeah, that's fine. We'll just throw int on these, right? There's going to be so much code cleanup on this project. Team and tier cannot assign type float to int. Well, this is definitely. Oh. That'll do it. There's some stuff that looks like it needs to be typed. But this does build. Does it eval? Nope. This needs to be uint or int 32. None type has no. That's fine. Self.cn. We don't need this. Cool. Dire level min. What's going on here? So it's not spawning anything, which is probably bad. Levels. Use. Entities.shape. 1206 entities. C entities.view numpy rec array. That's weird. Maybe this. Not convert shape to size 110. Why is this 1 by 206? Oh, env is 1. Duh, that's fine. So this doesn't need to be reshaped, right? That's fine. Probably doesn't need to be reshaped either. Shape T's. Step. Let's figure out what's going on here. I think that it's just that you need to do entities of 0 or whatever, because the environments are stored separately. Let's figure that out. I think what's happening is just like I have this structured element where it's expecting me to go here. Okay, 0 of 5:10 dot levels. What the hell attributes does it have? Oh, dot, yeah, dot. Yeah, there we go. That's not bad. No big deal. So the bigger thing now is that the just stuff is not spawning. I'll show you. So nothing is spawning here. So let's figure out that. So when we call reset, what happens? Self.tick gets set to 0. And is it resetting every tick or something dumb? This is dire victory. Let's just see if it's resetting constantly before it can spawn anything. Possible. I don't think so, though. Oh, I'm right. That's real funny. Get tower 22.health. So I guess when we spawn the towers... Oh, we forgot to spawn all the towers. Duh. Spawn all towers. And now, if we run this... Hopefully stuff works, maybe? Okay. I suspect it's not going to reset fully cleanly, but... There's your env. Dire victory. That actually looks like it reset relatively cleanly, right? Maybe there were leftover creeps or something, I don't know, but scheme of things, that was a relatively clean reset. Cool. Let's add like games played or something. Well, we'll do that later. Let's just get this thing to frickin' to run. So we'll rebuild this. Let's see if we run train. I want to see if we get rewards. Now, mind you, this is actually not taking into account the neural net actions at the moment. I just want to see if we can run the data through the pipeline and get some stats. Oh, there you go. Radiant level max, radiant level min. Runs. This is running, I think, 20 copies of Dota now. It's very slow. We haven't done any form of optimization on this. None whatsoever. On the environment, obviously, we have. You can see the forward pass is taking up 71% of the compute. So, how's our memory usage on this? It's a good question. If this is leaking, then we're going to have issues. If not, stable 2.49. Okay. Well, we can do a little bit of optimization on this. This will be fun to see. We'll see how quickly we can get this to be stupidly optimized, right? I'm actually going to commit all this code up and start this on the big machine. Config ocean. It's actually really cool, though, that it has not crashed the environment through that whole time. That's pretty impressive stability out of this thing. 670,000 steps of Dota. I think that's, this thing just played like 3 hours of Dota. Now it's going to play 3 hours of Dota per second. Let's get it to that. So here is our bigger box, right? This has, this is in the puffer cluster, which I like to show off for the stream. So we're running this now on this hardware. This box right here. The Puffer AI mini cluster. It's literally a bunch of desktops in a garage. Pip install G. Nah, we can just set up .py. We'll get ourselves a baseline since this machine's way faster, and then we'll optimize from here. It'll be fun. The time zones for the stream are funny. It always gets more people looking at it at like 7 p.m. Pacific. So welcome, folks. Mode train, vec, multiprocessing. Okay. So our baseline is this train's at 14,000 steps per second. This is like the worst optimized possible. Many researchers would be very happy to have their Atari thing running at this speed. Now let's see. Config / ocean. We should probably just grab some args from like Snake, right? Or Grid. 8192. This batch size is really large. Let's do 8192 though, or 4096 to start is fine. I think you don't quite do 4096 because I think it's 4090, which is funny because it's the number on the GPU. Then we have to do, ooh, the thing's kind of made for powers of 2. A little awkward. Not a big deal. 4090 times, I don't know, 16 times 16. 65,440. Okay, and so what we're going to do is we're going to run... This is 409 copies of DoTA per core. Hopefully we have memory for this. I think we do. So we're just going to set this numems is going to be 409 ems. Let's hopefully not crash my box. Okay, well that works. I forgot to increase the config. So we just did the amount of training we did before in like a second. I told you this was gonna be fast. Billion steps. 7 million. There we go. Okay, so we're at 500,000 train steps. We should be able to get 1 million. I'm a little curious as to why the env is running that slow. %. It should be way faster than this, based on our profile. I mean, we could always just increase the core count and stuff. It's possible we made it a little slower and might have to do a little bit more optimization based on the reset stuff we did. Let's do this MOBA perf thing. Numems is 409. We'll run this for 20 seconds. It's possible it's just substantially slower. In which case, we can do more optimization on it. We have more cores than 2 for now. Yeah, so this is now only getting 700,000 steps per second, which you would still think would be enough. Maybe not. Let's just, let me try a few little things real quick. Just to make the math easier on myself, I'm going to do this. It's going to be 100 environments exactly. Ocean, was it? So we're going to do number of environments. This is per 100. So let's do... We need 400 environments. So triple buffered. No reason not to do this, right? I guess there kind of is. 12. And then you need 4 environments. We do 24. 24M, something like this. This might be too much. We'll see. We can do 8,000 mini batch size now. Oh, actually, we should do 8. Yeah, this gives us better scaling, I think. And then we can do 160K maybe. Is this 16,000? No, we want 160K. Or actually, 8 times 16 is 64. So 128,000. Like, yeah, like this. Let's try this. Oops, not MOBA perf. Do we have anything running on this machine? No. Oh, wait, this grid continuous thing is still training, isn't it? Is it? Yeah, okay, this thing is good now. It's no longer eating my CPUs. So we just run it like this. Like multiprocessing. Is the chat working, by the way? Nobody said anything in forever. I'm assuming it's not broken. Okay, that gives us 600,000, and the env is down to 1%, which means we're no longer bottlenecking on the env whatsoever. This is very good. I see we have very high misc. Test, yep, it's good, thank you. Welcome. Okay, so I think we just need to match some train settings now, because this should be pretty much 1-to-1 the same with everything else. I guess maybe the continuous actions or something weren't handled correctly. Let's run it with discretize on. I might have to fix something. Do I have a discrete setting? Yeah. Bufferlib, environments, ocean, MOBA. Oops, MOBA. MOBA. Let's see whether I broke this or not. Python demo. Just run it like this. Screw it. Could not broadcast. Action space. Could not broadcast from shape 2 into shape. Fix this real quick. If is continuous. Got the MOBA model. It looks like this is good. Where is it getting actions of this shape from? Be getting them from the model, right? The actor gives you linear to 6. Oh, right, because this is not, this is not remotely correct. We need to compute this then. It's number of actions should be the sum of this vector up here. So 3 plus 3, this is 6. plus 10, 16, 20, 21, 22. Oops. Torch. 22, I think, right here. Six. It's not 6:9. It's 6:16, I think. Yeah, that's like 0 to 10. Perfect. And then, come on, autocomplete. Yeah, there we go. Does this work now? Right. I forgot to do... Oops. Torch. We just needed to comment this a little bit at the end. Cool. So now this network should be relatively reasonable. This stack is not doing me any favors. Stack expects tensors to be equal size. Well, that's not good. The thing is, since I'm not using these anyways, I can probably make my life way easier for the time being. We'll comment this. We'll put this back. And we'll do again, MOBA. Three. Not broadcast from 8 into 3 into 6. I do it wrong. So I'm basically here. I have this annoying action space that I just need to massage a little bit. Right, I forgot to update the other thing. So this is 6 plus this is 12. Ocean, MOBA, or Torch. So this is 12 here. Really? I thought I had this right. Oh, I'm just dumb. I just literally can't. Yeah, 3 times 6 is 18. Okay. Arithmetic. Cool. Looks like it runs. Then do vec multi. It should be faster, not slower. I do remember there being some weird bugs, though, in PyTorch. Like, some of the optimization operations. So if this is way slower, it's just a janky loss, we can fix that. And something's bullshit here. We're making the action space discrete for now. CBA with this. Making it a discrete of 18. That'll at least let us... I want to just perf optimize this tonight is all I want to do. I don't want to be dealing with annoying PyTorch-like quirks. Okay. Look, this is just going to go to a discrete rate 18 or whatever. And then this line has to get commented right here. If this still doesn't work, we've got something screwy. Very possible. It'd be screwy in the model. Didn't take this long to start up before, right? Okay, so I'm assuming there's just something weird with like the way, like we coded this with the continuous actions and then probably we just forgot something. I'm gonna put the continuous ones back. I'm gonna hope that we can just optimize around it anyways. There really shouldn't be a perf difference between the two if they're both done correctly. Okay, so I don't even know if we changed anything, and now we're at... Okay, so it slowed down a little, that's funny. But like 600K, with the end being fast. I'm seeing relatively high volumes of MISC traffic. Some of that can be infos. I don't see any info whatsoever, though, so I'm assuming... I mean, I set the info reporting interval to be very long. Yeah, there we go. That's the first batch. Got very high forward pass percentage time. And very high MISC time. That's like nearly 30% of the performance just in probably CUDA transfers or something weird. Perf degrades a little over time as well. On to optimization. Looks like it's going well too. Yeah, this is just the start. It's not actually learning anything right now. It is running the policy. But we're just kind of ignoring the actions and running a scripted thing behind the scenes. We're just trying to see if we run the policy to get actions in the loop with the environments. This is currently simulating 2,400 copies of DoTA at 10,000 times, and it's training at 10,000 times real time. The goal is to train at 20,000 times real time, so it needs to double this. GPU utilization is atrocious right now. It's at 35%. Let's take a look at some observation spaces, maybe. Well, this is also the weird continuous version, which we haven't tested as well, I think. So, what do you attribute low GPU utilization to? Demons. You know, demons. That's what you gotta do the RL exorcisms for. Gotta make sure that you, you pay your tithe to your reinforcement learning priest. It's mostly CUDA transfers and other bullshit, though. The old goblins. The old goblins. That's funny. The old goblins. Oh, funny. Let's see. Did we allocate this buffer stupid? Were we stupid with this buffer? Observations. No, you got uint8 here. So we have uint8 data. And then when we define the ob space, what did we define it as? uint8. So this is correct. We probably need to just get it working with the discrete action first. Since that's like the thing that's more likely to be stable. We just have to like redo. Oops. These numbers are actually fine if we just take like the 0 off maybe. We'll just do 10 per core as a little test. So let's MOBA. Shit, it's 7:25. I gotta get going soon. I hate to leave when the stream is like doing so well though. But I am pretty tired. I'll get this one last thing to work. Thanks for checking this out though. Always nice to see you drop by on this. We got lots of cool stuff working. I don't know if you saw, we perf optimized single thread to 1.3 million steps per second single thread. Which is what I promised, million steps per second, right? Where the heck is this stupid thing stuck? That took most of the day, though. This thing is just stuck. Right? Thing is just stuck being stupid. Are you implying it's running multi-threaded now? Yeah. And if so, how are FPS lower? Well, they're not. What you're looking at training throughput now. So yeah, if you're gonna look at training throughput, that's gonna be lower. That's gonna be GPU bottlenecked or CUDA bottlenecked or whatever. But and there's some circumstances under which the frames it'll drop lower as well, because we can't just have one copy of the environment. We need to have way more than one copy of the environment. So I think like when I was running 400 copies, it was going down to like 700,000 steps per second, which is slightly too slow for what I wanted to do. So I started doing some other fancy things on 24 processes with 2400 environments. There's a whole thing that's going on. But basically, like, you want to have the minimum number of environments that you need usually when you're using this many, of course. And you want the thing to run such that the environment is using like 0% CPU. or not 0% CPU. You're waiting on the environment 0% of the time. So you're never bottlenecking on the CPU. It always has data prepared for when you want it. And that you can reasonably do. What in the hell is wrong with this environment, though? I mean, Pufferlib's vectorization is drop-in. So, like, once... It literally took me 5 seconds to go from it being single-thread to multi-thread, because Puffer just does it for you, and it's fast. Now, the thing that we're dealing with now is, I don't know if it's a torch issue or, like, a thing that I coded with the env weird. Yeah, but something's jank. So... you get this thing. You return the action. It's continuous. This should be fine. It's getting stuck on the environment. It shouldn't be doing anything with these actions. It literally shouldn't care what it's getting for actions. Step all. Render. I don't need this. Infos. This is dumb. And discrete. We got this thing running discrete, yep. One, two, three. It runs a few steps and then just gets stuck. Doesn't make sense. Why the hell would the difference of actions make it get stuck? Or is it even getting stuck? Is it getting stuck on receive? Yeah, it's stuck on the vec environment, which is very weird. So the environment is hanging, I guess. What if we do it single thread? One. Does it hang instantly then? Segfault. Yay. Oh, I know. I think I know. No, wait, I don't know. I thought I knows. I thought I knows. One idea. One idea, and then I'm going to, I'll answer a couple questions if anybody has any cool stuff, but then I'm going to go get food, because that's probably a thing that you need to do. Action space. Where do I make self.actions? Right here. This is float 32. Self.discretize. Okay. Let's do... This is false. Self.discretize. This has got to be false. I bet it's just doing something weird with the underlying env. just pass false. I leave the actions. Let's see. Works instantly. Move on. It was just like a weird typing issue with a thing I was passing to the end, breaking it. QDNN not supported. That's weird. Okay, let's actually set this thing to use a reasonable batch size now. Buffer lib. 100 Ms per core. Usually you want like 8, was it like 8192 mini batch? DoTA doesn't divide by powers of 2. We try this. There you go. So, it does like to dip a little bit after a second of training. I don't quite know why. But that's up to 800. I'm sure we can get that stable. It looks actually pretty... Well, of course, as I say that, it flags. Very, very weird, actually, that it dips in steps per second like that. Because, the environment is not taking up any time. You can see it. So... I don't actually... There's nothing here that should be variable speed. Do I have something else running on this machine? Like... That's pretty weird, the way that just happens. Could technically be infos, could be a number of things. We'll figure that out, I'm sure. Whatever that is, there should be no instability. So if we see 800K, we should be able to get 800K. And then with some additional optimizations, let me see. What do we do here? Batch size, BPT Horizon 16. Update epochs. Config. I don't see anything here that's bad. There shouldn't be too. Yeah, nothing there looks obviously bad. Except the BPT Horizon, which isn't going to help us. Yeah, but... 600K. We saw 800. We'll be able to get it. It's the same exact architecture as the grid environment. So there's actually no reason that we wouldn't be able to match it. There's like some jank under the hood that we'll have to debug. I'm going to commit all this up so you guys can play with it if you want. Reminder, it's not actually like learning stuff yet. It is running. It's not learning stuff yet. MOBA. Okay, it's in any config. Tomorrow I'm going to try to actually get models training on this properly. So we're going to probably set up like a proper or a reasonable multi-discrete space to start with. We're going to set up the actions to actually control the agents. We're probably going to set up some sort of scripting thing for targeting, because targeting is going to be really janky to represent early on. But they're going to be able to control movement, QWE, all that. And we will see if we can actually get the models to like do something reasonable. That'll be pretty cool to do. And yeah, other than that, I think it's pretty much set. Technically, we could probably even mix in like some semi-supervised data, which would be fun. But yeah, that's pretty much what we have for today. Let me show off for folks that missed it. We posted a few good things. Yeah, 1.3 million steps per second single thread, which is like over a gigabyte a second of data, simulation data. We started at 150K, took about 6 hours. It was a mix of low-level C optimizations or Python to C conversion optimizations, a few algorithmic things, and then one big one was a little bit of caching that we did. We fixed a whole bunch of bugs along the way with this thing. We got it integrated with the neural network policy just in the last little bit. We got the env resetting relatively cleanly. And this is now all committed up. So the goal for the next couple days is going to be to try to get some reasonable policies. I've done this type of a thing before, and the biggest problem is usually just tons of game bugs and figuring out all the stuff that's broken with the game and broken with the observations of the game. We also don't have we don't really have good high quality observation data yet either. So I have some methods of getting better observation data that aren't going to be too hard. We'll probably play with that a little bit as well. But I think that at the time being, like, we should probably be able to learn a policy that will play and win the game. High quality observation data. It's just really hard to extract this portions of local state data you want from the game and put them efficiently into a data structure that goes into a neural network. So like the ways I did a whole segment on this where I was like looking at different data structures. Yeah, the thing that you have to do is you have to find a way to represent the data in a way that you have a fast neural net that can process it, and not everything is fast. Hello and welcome. This is the little the tail end of the stream, 7:40. I gotta go grab dinner. I will be back on this tomorrow. I've been streaming the dev on this project pretty much every weekday. I just pushed all the code, so needs a little bit of cleaning up, but it's in this ini config branch in pufferlib. It is all open source. Go ahead and star the repo on your way in. It helps me up a whole bunch. And yeah, I hate to end the stream on when we have actually pretty nice viewership, but I gotta get food. So thanks all. I'll be back tomorrow.